Displacement with constant acceleration. It is a topic that we started this week. Do you remember the formula that we're going to be using for this topic? It's a very simple formula. It's not the triangles. Okay, it says displacement with constant acceleration. In this topic, the formula is not the formula for acceleration is not the... Wait. Okay, sorry. Sorry for the interruption. I don't know why they're interrupting my class. Anyways. Okay, the formula that we use in this topic is delta x, that is equal to 0.5 or 1/2 the addition of the two velocities, initial and final velocities, multiplying times the time. Okay, remember that delta x is displacement, and we measure displacement in meters. Okay, if it's not in meters, you have to convert. We have the initial and final velocities, and they're going to be measured both in meters per second. Another words for velocities are speed, okay? And then, of course, the time. For the time, we're going to be using seconds, okay? Now, in this exercise, it says a bicyclist accelerates from 5 meters per second to 16 meters per second in 8 seconds. Assuming uniform acceleration, what distance does the bicyclist travel during this time interval? So, as I told you the other day, in physics, in word problems of physics, we're going to have keywords such as from and to. From indicates what? Initial or final?
Initial.
And to represents final, okay? So it says that a bicyclist accelerates from 5 meters per second to 16 meters per second in 8 seconds. So what is the information that the problem is giving me? Let's write the givens. It says from 5 meters per second. What is that?
That's velocity.
That is velocity. From 5 meters per second, I'm talking about initial. Just because it says meters per second, I know it is velocity. So this is going to be velocity. And because it says from, I know it's initial. So initial velocity is going to be 5 meters per second. You can also write meters per second like this. Okay, like a fraction. You can participate in the chat as well. Okay. Okay, now they're in. Thank you for letting me know. Guys, when things like this happen, just you can open your microphone and say, Miss, there are people in the waiting room, because sometimes I don't see the notification bar. Okay, I don't see that there are people in the waiting room. Sometimes I make people wait too much because of that reason. So anytime you know someone else is in the waiting room waiting to get in, let me know. That's always going to be something good. Okay, so we were saying about the givens. Okay, from 5 meters per second is telling me that I have a velocity, and the word from is a keyword that represents initial something. So in general, this part of the problem, from 5 meters per second, is going to be 5 meters per second, my initial velocity. And then it says to 16 meters per second. So this is still, my units are meters per second, therefore that is the velocity. And because it says 2, it's going to be my final velocity, and it's 16 meters per second. Then it says in 8 seconds. So of course this is going to be the time. Delta t equals to 8 seconds. Now the problem is asking me what distance does the bicyclist travel during this time interval? It's asking me about a distance. Distance is just another word that we use for displacement, okay? So basically in this part of the problem they're asking me to find displacement. I need to find delta x, which is going to be unknown. So now that I have all my given ready, I need to see if I have to do a conversion. Question, do I need to do a conversion here? Meters per second, meters per second, second? No, I don't need to do a conversion, okay? So my step 0, that is about conversions, is not going to be necessary. It's not going to be necessary because all my given are in the units that I need. So now I continue with my next step, and is solve for the unknown. You write the formula. Displacement equals to 0.5 the velocities, and they are multiplying the time. Now all I do is substitution of my givens. Initial velocity, that is 5 meters per second, plus final velocity, that is 16 meters per second, multiplying the time, that is 8 seconds. I'm gonna solve first what I have here in the parentheses. So I have delta x is equal to 0.5. 5 and 16 makes 21 meters per second, multiplying 8 seconds. How much is this in total? Javier, turn the camera on. That's good. Thank you, Kenzie. Yes, the answer is correct. 84 meters. So what does the answer mean? The question says, what distance does the bicyclist travel during this time interval? Okay, so from the moment the bicyclist began to accelerate from 5 to 16 meters per second, that happened in 8 seconds. In 8 seconds, the distance that he traveled was 84 meters. Okay, during 8 seconds, he traveled 84 meters. That's the way that you can use to analyze your data, okay? Now, sometimes the problems are going to ask you something different. Like sometimes it's going to ask you to find the seconds, and some other times it's going to ask you to find any of the velocities. So what do you have to do? You have to isolate. So from this equation, you can work with these isolations, okay? Take a look. This is an equation already given for delta x, okay? Now, if you want to isolate for the time, I need you guys pay attention here. If you need to isolate for the time, you need to analyze. all these are multiplying the time because they are in the same line. Okay, imagine that this was a fraction, they are multiplying. Okay, so what happens when you isolate? You're going to send all this to the other side to divide. So in the case that you want to isolate for delta x, for delta time, it's going to be equal to delta x divided by 0.5 initial plus final velocity, and this is going to be your equation for the time. In case that you want to find the time, that's the isolation that you have to do. Okay, I repeat, you're going to move the two terms, the 0.5 and the parentheses, are multiplying the time. So if they are multiplying, when you isolate, you send them to the other side to divide. It's like in math. For example, you say that x is equal to a times b times c, and you want to know what c is. A and b are multiplying c. So if you want to isolate, you're going to send ab to the other side to divide. That's exactly what I did here. The only difference is that instead of a, I have 0.5, and instead of b, I have parentheses with the velocities in it. But the idea, the isolation idea, is the exact same. Okay? So in the case that you need to isolate for the time, this is the equation that you have to use. Now, if you need to isolate for any of the velocities, it then is a little bit more complex, but still you can do it. But better, I'm going to show you an example of that. And this example is from the homework that you're going to be doing, okay? But I'm not going to do your homework, okay? I'm not going to do your homework. So it says, a car enters a freeway. I'm going to change the data, okay? Because remember, I'm not going to do your homework. Okay. So I have this. A car enters the freeway with a speed of 6.4 meters per second and accelerates uniformly for 3.2 miles in 5 minutes. How fast, in meters per second, is the car moving after this time? So in this example, okay, I'm talking about a car. And this car, it says, enters the freeway with a speed of 6.4 meters per second. Then here it mentions the keywords, that is, accelerates uniformly. That is the keyword that is going to authorize me to use this equation, okay? And it says that this acceleration occurs for 3.2 miles in 5 minutes. So here they are giving me miles and they are giving me minutes. So I'm going to write my data. So it says a car enters with a speed of 6.4. What is this? Is that velocity or speed before or after? Before or after? Read the problem. In the problem it says how fast in meters per second the car is moving after this time. So in the question they're asking me a velocity or how fast. Okay, how fast tells about speed. Okay, and if it is about speed, it's about velocity. Now it says how fast. in meters per second is the car moving after. So in this case, the velocity after, I'm talking about a final condition of something. Final velocity is unknown. This is what I'm going to look for. Final velocity, which means that the part that says enters with a speed of 6.4, enters is a keyword that tells me an initial condition. How fast did the car enter? At 6.4. So that is going to be my initial velocity. 6.4 meters per second. Now, 3.2 miles. What is that? Miles is a unit for distance, okay? Which is also going to be known as displacement. Here I know my displacement. I'm not going to look for displacement, okay? Then it says 5 minutes. What are the 5 minutes? 5 minutes are unit of what? Of time, okay? So delta t is going to be 5 minutes. So, in my step 0, what do I do? Do I need to convert 5 minutes to seconds. Do I need to convert something else?
Yes.
The miles to meters, okay? So I do my conversions, 3.2 miles, and then 5 minutes, okay? How many meters I have in 1 mile? How many meters I have in 1 mile?
1,609.
Exactly. 1,609 meters in 1 mile. And how many seconds I have in 1 minute?
60.
So here you have your conversions. How much you got in the first one? You can participate in the chat. I got 5,000. Did you get the same? 5,148.8 meters. Did you get the same as me? Okay. Yes. And about the minutes? 300. That is correct. Okay. So conversions are done. What I need to do? I need to solve for the unknown. My unknown in this problem is final velocity. Okay. So this is my main equation, delta x equals 0.5, initial plus final velocity, delta t. So the first thing that I'm going to do is I will isolate for my parentheses, because inside my parentheses I have the final velocity, which is what I'm looking for, okay? So 0.5 is multiplying the parentheses, and delta t is also multiplying the parentheses. So to isolate, I'm going to send them to the other side of the equation to divide. Okay? So my isolation will be delta x divided by 0.5 delta t is equal to my parentheses, that is initial velocity plus final velocity. Okay? I have displacement, I have time, and I have initial velocity. All I need to do is to isolate. Now, I don't need my parentheses anymore, so I'm going to get rid of them. So my expression, it looks like this now. I still need to get rid of the initial velocity to isolate final velocity. So in here, my initial velocity is doing an addition, okay? Is adding to final velocity. So when I isolate it, when I move it to the other side of the equation, it's going to be doing subtraction. So you say delta x over 0.5 delta t minus initial velocity is equal to final velocity. And now you can plug in your givens because you have the equation already isolated for BF. So we say delta x. What is delta x in the problem? Delta x is 3.2 miles, but we're not going to be using the miles. We're going to be using meters. The meters that we got from the conversion. 5,148. Going to continue this here, okay? So I say 5,148.8 meters divided by 0.5 of the time. How much time I have? I have 5 minutes. There are 300 seconds, okay? Minus the initial velocity. Initial velocity, I don't need to convert, so I just write it the way it is. All this is equal to final velocity. Okay. First, I'm going to solve for the bottom part. 0.5 times 300 is 150. And now that I already solved the bottom part, I'm going to divide. Now that everything is solved, I'm going to divide, okay? 5,148.8 divided by 150. This gives me, write in the chat the answer you got. Valeria? Exactly, yes. Exactly, if it's in seconds, you don't convert. From this division, guys, I got 34.32, 33 rounded. The units are going to be meters up, seconds down. So it's going to be meters per second. Meters up, seconds down, okay? Minus 6.4. And this in total gives me 27.93. This is equal to my final velocity. That is going to be like the more difficult kind of example that you could do, because this isolation is a little bit more complex than the other isolations, but still, if you are organized with your procedure, you're gonna do it fine. Remember to keep the parentheses with you, okay? So these parentheses, try to work with these parentheses with a single thing, with a whole number, for example, and you isolate this one in the final place. Remember, you first are going to solve for the denominator, 0.5 times 300. Then you will solve for the division, 5,148 divided by 150. 150 is the result of multiplying 0.5 times 300. Okay, so you solve for this division, you obtain 34.33, and in the last part you make this subtraction. 34.33 minus 6.4, that gives you in the end 27.93 meters per second. And if a problem in the problem asks you to find the time, this is the equation that you have to use. As a homework, during this weekend, you're going to work in the practice problems that are in the page 49 or 51. It depends on your book. Okay? It's this one. Those 4 exercises, you will work with them as a homework, so you can practice this topic. Okay?
This program is to be the same today.
No. On Tuesday, I will explain a new topic, and then in the week 9, yes, I will evaluate this topic and the topic from next Tuesday. Okay, now we're gonna be okay, because the class hasn't ended yet. Okay, now in this new topic, I know that I say that they are a new topic, but actually it's the same topic. It's the same topic. Okay, this is what we know as kinematics. The next formulas that you're gonna be seeing, as you can see, all of them are based on the idea that we have constant acceleration. But what's the difference here? That now acceleration is part of the givens, as you can see. Okay, so we're gonna have this. Yes, there are many more formulas, and you're gonna have to get used to it. I like to transform this last formula to a simpler one, because when you use the 1/2 like this, you tend to get confused when you isolate. So I prefer that you guys use the decimal number, that is 0.5. So these equations are for the same, to find displacement or velocity. Okay, so delta x in this case is equal to the initial velocity times the time plus 0.5 acceleration delta t squared. And the other equation is final velocity equals initial velocity plus acceleration time. Do you have to memorize these equations? For that quiz, I'm going to allow you to use cards, okay? Because you're gonna be using a lot of equations. So for that quiz, I will allow you. Now, what is the difference between these formulas and the formula that we have seen so far? In this one, as you can see, the acceleration is given, okay? The acceleration is given as part of the formula. In the formula that we had before, we didn't have acceleration. Okay? The problem said that the acceleration was constant, but acceleration was not part of the formula. In this case, it is. Okay? In this case, it is. What I'm gonna do is, because the class will end soon, we're going just to highlight the givens, and we're going to continue with this topic on Tuesday. Okay? In this exercise, it says, a plane starting at rest at one end of a runway undergoes a uniform acceleration of 4.8 meters per second squared for 15 seconds before takeoff. What is its speed at takeoff, and how long must the runway be for the plane to be able to take off? Well, the word problems are going to be for Tuesday. Okay? So, what does starting at rest mean? A plane starting at rest. What does starting at rest mean? I told you that this is a keyword. This is a keyword, okay? At rest. How is the plane? Moving or not? It's not moving. So we say that starting at rest, starting, initial, okay? And at rest, we're talking about its motion. So the velocity is going to be 0 in this point. It says at one end of a runway. You can make a sketch as well, okay? I'm not going to. Okay, at one end of the runway undergoes an uniform acceleration of 4.8 meters per second squared. What is this? Is that velocity, acceleration, distance, time? Acceleration. The problem is telling you acceleration. Now it says 15 seconds. What is this? Time, displacement, acceleration, velocity. Time. What is its speed at the takeoff? What is the problem asking me to find here? What is its speed? What I'm looking for? Velocity, acceleration, time, or displacement? Okay, velocity. Initial or final? So I'm looking for the final velocity. Okay? And then it says, how long must the runway be for the plane to be able to take off? How long must the runway be? When I talk about how long, sometimes I talk about time. But this time, it says, how long must the runway be? ¿Qué tan largo tiene que ser la pista? So what I'm looking for, displacement, acceleration, or velocity, or time. Displacement, porque estoy hablando how long is the runway. How long is the runway, okay? So I'm looking for delta x is going to be my other unknown. Write this word problem in your notebook so we can continue in class on Tuesday.